Welcome, ladies and gentlemen, to our first lesson about vectors. You should get out this note paper, or we're going to be writing on it today. We're not going to do all of it, but we'll do a good chunk in the front and part of the back. So, to understand what vectors are, you have to first know what a scalar is. And you can think of scalar as just number. We use scalars all the time, like how much people weigh, how warm it is outside, how much space is in a box. Like, those are just a number. Like, it's 30 degrees, it's 50 kilograms, it's square feet, cubic feet, things like that. Well, those are scalars, those basic numbers that you know. And then there's these things called vectors. And vectors have both a number attached to them and a direction. And if you remember a quote from Despicable Me, when Vector introduces himself to Gru, he says he's committing crime with both direction and magnitude. Like, that's right. That is the definition of vector. It's got magnitude and direction. And we typically show them with an arrow. So like these here would be vectors. How long it is would be the magnitude, and then the direction is going to the direction. But you can also describe it in like words. A truck travels east at 80 miles per hour. The 80 is the magnitude of it, and the direction's east. Well, take a couple moments to kind of test your knowledge of, are these scalars or are these vectors? So go through these, was it A through L, and figure out which ones are scalars and which ones are vectors. Pause the video and then do that, and come back. All right, A here. This one's just a number. It's a temperature, so that's a scalar. On this one, the truck, while it does have a vector involved in it, it doesn't tell you the direction, and so it's just a scalar. The next one does tell you the direction, north, and the amount. That means it's going to be a vector. And the next one is neither. It doesn't have a magnitude on it and doesn't have an amount. It just has a direction. So D is neither. I'm going to put N for neither. And then E, this one's going to be a vector. It's upwards at 10 newtons. It's an amount. So there's a vector. On F, this one having a mass is just a scalar. But if we're talking about the weight of it, where the direction is down, that could be a vector. G, the box has a volume. That's just a scalar. There's no direction on it. H is neither. It has a direction, but no magnitude to it. I is also just a scalar, no direction. J is a vector. It's moving eastward at 15 meters. On K, the wind blowing from the south, it does have a direction. It has a magnitude on it, so it's a vector. And then on L, dropped into a pond, sinking at a rate of 30 centimeters per second. That is a vector. Sinking being going down, and we got a magnitude on it. So hopefully you can see the difference between vectors and scalars. Vectors can be written out in multiple ways, but the way we're going to be dealing with it is called component form. And the component form just tells you the change in the x and the change in the y. So a vector like this, that goes from 0, 0 to 4, 6, went right 4 and up 6, kind of like slope. And we're going to write out that vector form like this. 4, 6, and it's got these different kind of brackets on it. They look like greater than and less than symbols. And a couple things to note, the V with a line over it means it's a vector, but we can also use a bolded letter, so V bolded or V with a line over it, both mean vectors. And when you're getting the component form of a vector, it doesn't have to start at the origin. For instance, let's say we had a vector like this. It started here and went right so much and down so much, so you went right 5 and down 2. That means our component form for this vector is going to be 5, negative 2, because down and left are negative directions, and went down 2. So those are component form. So let's have you go to your assignment and try out a few of these and see if you can get the component form of the vector. Let's start with this one. Look at it, go ahead and write down what you think the component form is, and make sure you pause, do that, and come back. Alright, so according to my counting, it looks like this vector goes left 6, and up 9. So you should be getting the component form of this vector of negative 6, 9. Remember, the first part's the horizontal change, or the x change, and then the second part is the vertical change, or the y change. All right, jump to this one and see if you can get the component form of this vector. All right, according to my counting on this, it went left 8, but up 5. You do have to keep track of which end has the arrow, so make sure you're going from the side without an arrow to the end with an arrow. Otherwise, you're going to get your signs wrong on your vector. So on your assignment, I don't know if you noticed, but these are from your assignment, you'll be given some where it just gives you the initial point and terminal point. And this is saying the initial is the starting point, and then the terminal, as in terminate, meaning end. You need to figure out the vector as you go from the start to the end. This is a lot like getting slope, except you're going to write it out as a vector instead of a slope. And the way you can get your vector component form is going to be terminal minus initial. And you're just going to do x minus x and y minus y. And so my vector here is going to be 5 minus 1 for the x component, and then negative 4 minus 3 for the y component, and that'll give me 4, comma, negative 7. Okay? So you just take the terminal point coordinates and subtract the initial point coordinates, and you'll have your component form. All right, you try out this one. Go ahead and pause the video and figure out your component form of your vector. All right, you should have gotten 8 minus 2 for the x part, and then 9 minus 0. Remember, it's terminal minus initial, which will give you 6, 9, and voila, you got the component form of your vector. So pretty quick. There's another thing we're going over today, and that's how to get the magnitude of your vector. So the vector's magnitude is how long it is. If you look at our lovely vectors here, you may notice these are not like on the grid line, and so you can't just count it. But when we get our component form, we actually get our horizontal change and our vertical change. And this is a length problem now. Remember getting length not too long ago? Well, you're going to get length again. Magnitude means length. And the way you're going to get it is you're going to square root the x and then the y components squared and added together. And so if you had a vector looking like 5, negative 12, you'll square 5, you'll square negative 12, add them together, and then square root that, in this case, would give you 13. Let's try out a few from your assignment. Well, one quick thing. If it doesn't come out to be a nice whole number, there's going to be an exact value for it, the square root, none, where you haven't plugged it in, and then there'll be one where you plug it in and you round it off. So you have an exact value, an approximate value, just like when we're getting the length of things. So jump over to this problem, and this one is on your assignment, and let's get our magnitude of the d vector. And the way to show magnitude symbolically is 2 vertical lines on either side. So the magnitude of vector d is going to be the square root of negative 3 squared plus negative 4 squared, which will give you the square root of 9 plus 16, which gives you the square root of 25, which comes out to be a nice even number, 5. So the magnitude of vector d in this case comes out to be 5. Let's see if you can do this all on your own. Jump over to this problem, 5, negative 7 for vector e, and get its magnitude. Pause the video and come back. All right, go ahead and check and see what you got. Did you get the magnitude is the square root of 74? And that is about 8.60. You should have gotten that from squaring 5 and squaring negative 7. Remember, when you square a negative number, it's always going to end up positive. So make sure at this point you don't have any negatives after you squared things. 25 plus 49 is 74. So it's the square root of 74, which is about 8.6. And let's do one more just so you can check and see how you're doing. And you're getting your assignment done at the same time. It's wonderful. Go ahead and get your magnitude on this one. Pause the video. Alright, let's go ahead and have you check. You should have gotten the square root of 17. And that's because 1 squared is 1, 4 squared is 16, 1 plus 16 is 17. So it's the square root of 17. and the square root of 17 is about 4.12. It'd be great if you could do both the exact value and the approximate value. And that's it for our lesson. If you're getting these, you're in great shape as we start out our vectors unit. Have a good one.